Tonight, we've got a special presentation, programming a robot used by the Bonds Group. This is presented by Bonds, the Bringing Opportunities Near Dayton Students team. The Bonds team, 5811, is a FIRST Robotics Competition team. They are the group of talented, outgoing students, and their goal is to advance STEM, science, technology, engineering, and math all over the Dayton community. Their mission is to bring STEM opportunities to students in the local community through robotics. In their build session, students design, manufacture, and build a robot that will compete in a sports-like challenge against other national and international teams. The team will talk about the team and discuss how they use computers to program their robotics. Want to thank Mark Camden. Mark organized this. Mark is also a volunteer helping with the Bonds team here in Dayton. So with that, I'll turn that over to the Bonds team. I see they have their logo up there, and take it off, please.
Hello, we are Bonds Robotics, Team 5811. Bonds stands for Bringing Opportunities Near Dayton Students. This means that we're trying to bring STEM opportunities to our students, and we compete in FIRST Robotics Competition. This is our 10th year competing, and we run Bonds like a small business where everyone has a different role in the team. We have about 20 different students from 5 schools around the Dayton area, and we have student captains that directs the team, and we practice in K-12 Art Gallery in downtown Dayton. For our competition season, we participate in FIRST Robotics Competition, and we practice for 10 to 11 weeks, 5 days a week during the year to make our robot. We'll build the robot and split into sub-teams to do the build, the programming, electrical, marketing, and other categories. We participate in 1 to 2 competitions per year, and this year we'll be participating in 1. And we went to Worlds in 2016 and 2019, and we're hoping to go back again this year. This is a video of our past season.
Players, put your pinky rings up to the moon. Girls, what y'all trying to do? 24 karat magic in the air. Head to toe so clear. Look out. Pop, pop, it's showtime. Showtime, showtime, showtime. Guess who's back again? Oh, they don't know. Oh, they don't know. I bet they know as soon as we walk in. I'm wearing Cuban links, designer mix, Inglewood's finest shoes. Don't look too hard, might hurt yourself. Know to keep the color red, the blues. I'm a dangerous man with some money in my pocket. Keep up. So many pretty girls around me and they're waking up the rocket. Keep up. Why you mad? Fix your face. Ain't my fault they all be jacking. Keep up. Players only. Come on, put your pinky rings up to the moon. Got you covered when there's no one at all. Oh yeah, and I stay through the night when you got demons trying to break through the walls. There ain't no kind of line that I wouldn't cross if you need me to. You're out here searching for signs, so I think it's finally time that you knew. Nobody got you the way I do. Whatever demons you're fighting through, when you need somebody to turn to, nobody got you the way I do, the way I do. Nobody, nobody, nobody. nights get so cold, I'll be on my way to you. You know I ain't trying to lose you, oh no. If you're in hell, I go there too. There ain't no kind of line that I wouldn't cross if you need me to. You're out here searching for something. Nobody gets funny till it's true. Nobody got you the way I do. Whatever demons you're fighting through, when you need somebody to turn to, nobody got you the way I do, the way I do. Nobody, nobody, nobody got you the way I do. Nobody, 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 nobody got you the way I do. Nobody got you the way I do. Nobody, nobody, nobody got you the way I do. Nobody, 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 nobody got you the way I do, the way I do. Nobody, 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 nobody got you the way I do. That was when I ruled the world.
So this is what our t-shirt looks like from the front, and then this is what it looks like from the back. Our robot's name this year is going to be called 007. It's a reference to James Bond's 007, 007. And actually you can see that DMA is right there on our sponsor list in the back, which is pretty cool.
And next up, we have some of our team's accomplishments. In 2016, we won the Rookie All-Star Award. That was when we were just a new team, and we were able to go and compete at Worlds. And in 2019, we won the Industrial Design Award for our robot and the Chairman's Award, which is one of the more prestigious awards, and we're able to compete at Worlds. We also had 4 Dean's List finalists and 1 Dean's List winner at Worlds. The Dean's List, it's basically a specific member of a team who showed outgoing, like all the values and morals of FRC and the whole program. So like the kind, the caring, the committed, all that stuff. And then we nominate them, and it's a whole thing. And then it is the top award for an individual participant. And then in 2022, WV Rocks semifinalists, and we also won the Spread the Word Award. I think it's Y Rocks. I don't know.
It's WV Rocks.
Yeah, WV Rocks. It's one of the unofficial FRC things where basically after the main competition, you can still go there to like compete with other teams.
It's a really long competition. It's actually pretty fun. It's a 26-hour competition that happens overnight, and matches just keep going. You basically don't get to sleep, and it's really fun.
And then 2023, we got to the playoffs as the Alliance 7 captain. That was in the Miami Valley Regional, like down near Cincinnati. And then last year we were Alliance captain number 8 in the Buckeye Regional up in Cleveland, and we were Alliance captain number 4 in the Miami Valley Regional. And then our off season, we meet 1 to 2 times a week for 2 to 3 hours. We outreach to kids and other teens at community events to try to get more things. And actually, the way that I got in the team was we just saw a billboard passing by and we're like, hey, that's fun. And I ended up having a lot of fun. And so yeah, and we do an Air Force Museum trick or treat and the Oakwood Femineering Club to also basically that's so we do during the off season. We recruit new members, we talk to businesses interesting in bonds like you guys. And then we attend smaller competitions like WV Rocks, but much smaller. And then we fix up our shop and previous robots. Our computers and applications used by bonds. These are the stuff we use on like our computers and our build team. Me and Emily are part of the build team. Emily's actually the build captain. And and the build team is responsible for the design process, and they work in our shop with power tools and manufacture parts. The build team uses computer-aided manufacturing, CAM, software for manufacturing robot parts on a computer numerical control or a CNC machine. And it's quite interesting. And then our programming team, they're responsible for programming every robot that we create. And they write thousands of lines of code in Java every year, like from how much torque our motors use to the exact code on how to move from point A to point B in the most efficient manner. It's
We'll
pretty
talk
impressive.
about this. Well, I will talk about this
Yeah.
later.
It's pretty impressive. And then our electrical team, the electrical team responsible for wiring our robots. They work closely with both the programming and build teams, and we couldn't do like anything without it. And then continued, we have our computer aided design or CAD team. I'm mainly on the CAD team. And then the CAD team is responsible for our design process. Before building our robots, we need to design it in CAD to use the computer to aid in our design. And we use CAD software like Onshape to design robot assembly and all the different parts before they are built. And then our marketing team, they're responsible for keeping our website and social media up to date, as creating binders and they also create binders and flyers about the team. Marketing team also designs our shirts, banners, and the sponsor panel on each year's robot. And our business team, they're responsible for managing the budget and works of the marketing with the marketing team to create informal informational flyers and reports about the team. And then this year's competition, which we are building a robot for, and I've been waiting for this, is called Reefscape.
We have a video. We have the release video to show you guys.
Yes.
This will explain all the rules and stuff.
Welcome to the 2025 FIRST Robotics Competition game, Reefscape, presented by Haas. 2 alliances of 3 teams each compete to earn points by harvesting algae, seeding coral on their reef, and returning to their barge to ascend to the ocean's surface. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Prior to the start of the match, teams can choose to hang a shallow cage or a deep cage on their barge. Robots start each match at their starting line and may be preloaded with 1 coral. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave the starting line, remove algae from their reef, and place coral on their reef. If all enabled robots on an alliance leave the starting line and score at least 1 coral in auto, the alliance earns the auto ranking point. During the following 2 minutes and 15 seconds of the match, drivers control their robot. Robots can place algae in their net and collect coral from human players at their coral station to place on their reef. Coral placed higher on the reef are worth more points. If an alliance can score enough coral on all 4 levels, they will earn an additional ranking point. Robots can also deliver algae to their processor. Once processed, the algae can be taken by the opposing human player and scored into the net. When 2 algae are delivered to each processor, both alliances earn a co-op point. The co-op point reduces the number of coral needed on the reef to earn the ranking point and influences a team's rank in the tournament. As time runs out, robots race back to their barge to hang on their cage and ascend to the ocean surface. Points are awarded to robots that can hang on a shallow cage, and even more points are awarded to robots that can hang on a deep cage. An alliance that scores enough barge points will earn the barge ranking point. The alliance that earns the most points overall wins the match.
All right, yeah, that was an overview of everything that we have to do this year for competition.
That's what our
Do you have any
robot
questions?
perform.
A couple questions. What is the youngest age person with your group?
That would actually be me. Me and my friend William are the youngest people on the team right now. And even though I am the youngest, I'm only in 8th grade. There's still a lot for me to do around to help out.
And your age?
And I'm much better. Like I have learned a lot of skills from my time here.
Yeah, and they actually joined last year as well when they were in 7th grade.
Yeah.
So they were younger then, but yeah.
Mhm.
Those two, despite being both younger than me, have been on the team longer than I have.
Yep.
I'm a freshman, but I was on the team last year as well. So yeah.
I'm a junior. Any other questions? And before I move on to programming, that is.
This particular video that we were looking at is that the main focus of your competition, or are there other competitions that do different things?
It is the competition for
Yeah.
this year. This is what we will be doing with our robot. This is what we've been designing our robot to do to, get the most points and win the match.
Yeah. So every team has the same thing, which is this. And then next year there'll be a different theme.
Yes, it's different every year.
How much lead time do you get to prepare your robots for this
About-
competition?
We have 11 weeks
Yeah.
every
Like 10 to 11 weeks.
year pretty much, and we practice 5 days a week. So yeah.
So this video was given to you 11 weeks ago, and you're to prepare your robots for this particular
no.
task?
We have
It's like
11 weeks.
6 weeks ago,
We
maybe.
have like 4 weeks or 5 weeks. We have 5 weeks until competition. So it's been this is like week 6. So 6 weeks ago we received this and we immediately strategized and then came up with our robot design, and we've started manufacturing.
Competition since then.
Yeah.
Yeah, unfortunately, our Cleveland competition didn't get enough funding to happen this year.
All right, we're gonna move on to programming. So we use Java. Java is a programming language, as I'm sure you probably know. We use this language to program all of our robot. Well, okay, with a few caveats, but mostly we just use Java for our robot. But before I can get into the actual code itself, I'm gonna talk a little bit about the wiring of the robot and how it connects up. So there we go. So this is an image of our practice chassis. This is not our actual robot because wiring on an actual robot isn't done, so I can't really show it off. But this is on a test chassis, and the thing that is circled, that is the RoboRio. That is the brain of the robot. That's where all the code goes, and that's what actually runs everything on the robot. It connects the motors, the whatever stuff is on the robot.
Robot can't run without it.
Yep. It is quite literally just the brain. This is our radio. That is actually the radio we're going to be using for competition this year. It is new from last year, and it is what we use to communicate between our computers and the robot itself. It's connected to the RoboRio via a Ethernet cable. These are motor controllers. We aren't using those specific motor controllers. We're using different ones for our robot, but they basically serve the same purpose, and they translate power signals into motor outputs. So you give them some sort of signal and they transfer it to the motor and tell the motor what to do. Really, the motor controllers are connected by the RoboRio, which is connected by the code that we write on the computer. And then the motor controllers control the motors. All right, so now I'm going to talk about the actual code itself. So what we do on the computers. So we have the driver station, which is what we use to communicate with the radio through our computer. So the driver station has a bunch of features. This screenshot that I have is the main page, which is what we'll usually be using. And here we can control the robot status. So like if it's teleoperated, if it's autonomous, if we're testing something, or if we're practicing, there's 4 different states. And then we can also disable the robot in case there's an emergency or some other reason that we have to disable it. In here, we can also check the status of our communications. So are we connected to the radio or not? We can also check our joysticks. Do we have input devices connected? Are they connected well? Did they actually provide input? And we can also check if the robot code is running on the RoboReel, which sometimes it's actually not because our code crashed or some other reason. There is another tab, which I have not shown here, but the other tab basically shows us all the inputs that are going on. So if we connect a joystick, we can see, axis 1 is forward and backward, and we can see the value of axis 1 so that we can do some debugging. And that's really what the driver station does. It allows us to look at states on the robot, control the states on the robot, and overall communicate with the robot in a way that humans can understand. So here is some of our actual code. So we use what's called command-based programming, which means that we make commands to run the robot instead of just directly running the robot through code. So what this means is in Java, there are classes, and there's a dedicated command class that we use to make commands for the robot. A command is basically a series of steps for the robot to do. It has a few built-in functions. I'll just go over the functions. The first function is initialize, which gets run every time the command is called. So say I have a command to run the drivetrain forwards. Then whenever that is called, I can put some code in initialize to run when that function is called or when that command is scheduled. There's another thing, there's execute, which runs 50 times a second, ideally. Sometimes it'll be slower because processing, but usually runs 50 times a second and is what we use to mostly control the robot because it's a periodic function. And we can continuously input and then output and input and output. And it's the most convenient way to control the robot. The other major function of the command class is finished method. Basically what that does is we can tell the command, is that command finished? So are we ready to release the subsystem that command runs from that command? So are we ready to basically have another command take control of the robot? I'm gonna pause here for a second because I just went over a lot of stuff. Any questions about what I just went over? I'm gonna assume that's a no. Okay. So here's a list of all the commands that we have for this year's robot. I'll go over them one by one. So our align reef command, I should probably pull up a reef thing, but on the field, there is a reef on each side of the field. And then on each side of the reef, there are 2 branches of stuff that we can put coral on to score points.
The reefs are hexagonal, by the way.
Yeah, there are 6 sides of the reef. The align reef command basically does, what it does is it tells the robot, find the closest reef side and then go up to it and then just kind of sit there. It doesn't do anything else. Usually commands are like this. They're pretty simple. They do a specific thing, and then we can use a different command to do something else. It makes all the programming pretty clean. Align reef no pathing is the same command, but we get rid of pathing to make it faster and more accurate. That is actually the one we'll be using this year because the pathing is unoptimized and it kind of sucks. Autos, we don't really use that one. It's a primitive way. It's kind of an easy way to do autonomous, but we don't really use it because we use a different way to do autonomous. Example is an example command. We just kind of reference it. Reset swerve pose. So our drivetrain is a swerve drivetrain, which means that each of our wheels can can drive, and we can turn. Why do I feel like we're not connected anymore? Oh, we are. Okay.
Basically, we don't have to do 3-point turns. We can turn all around without even switching to
Yes,
rotation.
each one of our wheels can turn and drive individually, which means that we can do all sorts of wacky stuff. Like during off season, I even programmed the robot to do donuts at some point, which is pretty funny. We have our the reset swerve pose command tells the robot that the robot is at this position instead of whatever position it thought it was. Stay on point command is a command that tells the robot to stay on wherever it was and not move. This is really helpful because during competition, there is a strategy we call defense, which is when another robot tries to knock a different robot out of the way so that they can't score points.
Or just block the path entirely.
Exactly. So say we're trying to score a quarrel and we're driving over, right? And then another robot from the other team comes and bumps us. Now, all of a sudden, we aren't aligned properly anymore and we can't score. So what that command does is it helps us stay at the place to score so that if we get bumped, we won't just lose that quarrel. Our swerve teleop command converts joystick inputs into driving. So it turns inputs from a joystick into the robot driving. So we can go, I don't have a joystick to show you. If we can go forward on the joystick, the robot will go forward with us. It's pretty self-explanatory, really. Our vision teleop command controls our cameras. We have 2 cameras mounted on the robot. There are basically QR codes on the field that help the robot align itself, assuming we have a camera. And because we have 2, we have a dedicated command to control them and take inputs from them so that we can estimate our robot position on the field so that we can use it for alignment and other things. The zero elevator encoder command is self-explanatory. It zeros the elevator encoder, which is a thing that detects how many rotations our elevator motor has gone through. If you want to see any of this code, I can show you. I have it pulled up. Okay. Here's our list of subsystems. So we have our basic drivetrain subsystem, which is our swerve subsystem. It controls our drivetrain, helps us move around, basically. Our elevator subsystem controls our elevator, which I'll actually show later. It is a mechanism on our robot that raises the game piece up so that we can score on the higher branches of the reef. Swerve module isn't really a subsystem. What it does is it contains a single wheel, because the swerve controlling is kind of complicated, so we need a dedicated class to deal with the controlling of a single wheel so that we can pass it into the actual full drivetrain subsystem. It's kind of complicated. The vision subsystem controls our cameras. I don't know what else to say about it. It controls our cameras.
Explain what the drive is, what a swerve drive is.
I already did.
Oh, okay.
So here's an image of our robot. So this is mostly without wiring. You can see some wires already in place, but this is mostly just bare bones. So this is our elevator. Our elevator is that central thing. It's currently clamped down, but without it being clamped down, it can raise up
To
how high? 77 feet?
7 feet. It has 3 different segments. That basically it raises up segment by segment until it's high enough, and we can adjust the height to use this carriage part. That's what actually holds the piece of coral. So we adjust it to the height we need to score on the different parts. And it can adjust up to 7 feet. So we have enough. And then we also, to get the wires up there, we use an energy chain that is attached to parts of the elevator.
That's not in yet, but
Yeah, it's not attached yet, but
it's in our plans.
yes.
The carriage is also not mounted. That black box is not actually the carriage. It's the place where the carriage is going to be mounted. The carriage holds the game piece, by the way, whenever it gets raised up. And it can also eject the game piece when we score. We also have...
segments.
Sorry?
How tall are the segments for the elevator?
There
Vertical
It's
section.
up to 7 feet. So it's
3 segments. It's 3 segments, 4 if you include the carriage. but it's maybe just 3 seconds.
So when fully extended, the elevator can go up to 7.
So each segment's about 2.5, I guess. Okay.
What? Excuse me, what did you say?
Let's try to determine how tall the segments were.
Oh, how tall are the segments? I don't actually
Segments
know.
are about, they're all like around the same, I think they're all around the same height, they just differ in the width, so like,
You're asking how tall.
Yeah.
yeah, but they're all like same height, so around, let me do a quick math. It's like a couple.
Less than two
Yeah,
and a
just
half
like-
feet. Yeah.
It's around two
Two
and
and
a
a half,
third.
yeah, like 2 1/3
2 and a half,
foot.
2 and a third-ish.
Yeah.
Yep.
Okay, so the last subsystem that I mentioned earlier is the drivetrain, which you can't really see the wheels, but they're there. Those are swerve modules. They have 2 motors controlling the drive, which is going forward and backward, and then also the turn, which is just turning the wheels itself. Yeah, I think that's all we have. There is another little thing, but I'm not going to talk about that. It's kind of minor.
It's basically a little thing that pops up to just knock off algae off of the reef.
So this is some of our initializing classes. These don't really do a whole lot in terms of physically controlling the robot. They just initialize our robot code and communicate with the driver station what state we're in and stuff like that. They're hard to explain. They initialize our code and that's about it.
How many wheels are on the chassis?
We have 4 wheels.
Thank you.
Oh, we'll take them out in the shop and show them.
We can yeah, we can show you our current robot if you want after the presentation. Yeah. All right, so that concludes all the programming basically. Once again, if you guys want to see the actual programming, I can show you. I have it ready. All right.
Yeah, let's go ahead and see that.
Oh yeah, okay. So here is our current code. You'll notice that I have added a couple things from the screenshots. There is a lot more commands. Because of the way that our autonomous sequence works, we need 3 separate commands, very small commands, to deal with the 3 levels of the reef. As you can see, our commands have an initialize function. And then this command specifically, it actually creates a new separate command which handles the actual controlling. Let me see if I can find that. This. And then within this command, we actually call a subsystem method, which is the elevator subsystem. And then elevator is here. Within this, we then control the motors to go where we want. So for the elevator, that's pretty simple. Only about 104 lines, as you can see. But for our swerve, it's much more complicated. The swerve subsystem itself has a bunch of methods, a bunch of controls, a lot of debug. It's a lot of stuff. 200 lines, 240 lines of code. And that's not even counting the actual module code themselves. So this is everything that we use to control each individual module, so each individual wheel. And then all of this basically gets multiplied by 4 when we add it to the whole subsystem. Is there anything specific you guys wanted to see?
I don't think so, but in general, how many lines of code did we have to generate?
Oh, well, I would say around 2,000, maybe 3,000, give or take. Call it 2,500. 2,500.
Okay.
That's my final answer.
Not
Although,
bad.
go ahead.
Very good.
A lot of this, like here, is commented out. This is from last year. I was using it as a reference and I just never deleted it. So some of the lines don't actually do anything.
Mainly the dark green ones.
Yeah. Okay. I'm gonna finish out the presentation and then we can give you guys a shop tour and look at our robot and stuff.
Stop sharing at the top.
Should I finish
Is that
this?
the-
There's more.
Oh,
There's more
there's more
slides.
slides.
Yeah.
Okay.
Okay. So here's why bonds is important. We teach technical and soft skills. So every new student that comes here, we teach them basically whatever they want to learn. We have people that only want to do marketing,
Yeah.
and we can teach them marketing.
Like my
Yeah.
friend William showed up, he brought his computer, said he really wants to learn how to program and to code, and he is already well on his way to becoming a very good
I've
coder on
actually
the
been
team.
teaching him. He's pretty good.
Yeah, and I came in here really wanting to build, and hey, I'm helping build a robot, and I also found out that I really like CAD, and so this place also helps me find new things I didn't know I wanted to do, but hey.
It makes it a lot. It makes it really fun for new students. They get to learn a lot of skills that'll be helpful later in life. Some of the skills include engineering, CAD, machining, programming, public speaking, fundraising. Public speaking mostly comes from these business presentations. We'll prepare students to handle issues. So in building the robot, there's bound to be lots of problems. You can't build a robot perfectly. That's just not going to happen. There's going to be issues and people are going to have to learn how to overcome those issues, which is a nice real world skill to have. And we connect students across Dayton area. They come to robotics, connect with each other, have fun, build connections, networking, and we show them how fun robotics is. Maybe convince them to pursue a career in STEM related fields, or maybe even robotics itself. So here's how you can help. You've already donated money, which is great. We really appreciate that.
Can't run this team without it.
Yep. And something else that we could do is we do need more mentors. Mentors is a very useful resource to have because there have been many moments where a student just kind of stands there and doesn't have much to do because they don't know how to do something. And there's no mentor available. So it'd be really great if we could have more mentors available. Materials is also very important. We can't build a robot without materials. Yeah, so anything from our wish list, any materials really is going to be really helpful for us. Machines, we don't have the greatest machines. We have some pretty good ones, but they're not the best. We definitely could use more advanced machinery, more fast machinery, more precise machinery, that kind of stuff. And of course, you could also reach out to other people and tell them about the team. Maybe we'll schedule a presentation and we'll talk to them about it. So thank you for listening to this presentation.
Thanks.
Do you have any questions for us?
I would love to get you talking about the programming to the dynamic language group we have, because they talk about programming all the time, mostly in Python, but they would like to probably see your programming that you've done here and hear this stuff too. Whatever special interest.
Yeah.
They're always the second.
Well,
Wednesday
thank you
morning.
very much for the presentation. And for everybody here, notice the website, Bonds 5811. That's the local group. And you can get in there and see what they're doing, keep up with what's going on. The DMA has given them a gift of $1,000 to support this project. I know it's a small part of what it costs to do this, but we have done that. So we appreciate all of you spending the evening with us and enjoyed your presentation very much. Thank you.
So we were actually in a computer design area that we used. We share with the art gallery. We are now moving towards our actual shop and we'll show you around.
A lot of stuff gets placed. It's their messy table, but it's our messy table, and we love it dearly. This is Ava, one of our head mentors. She's awesome. And this is our build area. It's actually basically like the first little area that our team had, like all to ourselves.
We have all of our tools, resources, materials, the actual robot. This is one of our team captains, Oliver. And over here in this general area is all of our all right, you can talk.
So these are our bumpers. Table saw for cutting wood. These are a lot of our tools. This is a saw, a miter saw that we use very often for cutting pretty much anything. You can cut it just like that or at any angle that you want. The drill press. Bandsaws.
Bandsaws. Yep. And over here, we have some of our automated manufacturing. This is our Ilmio.
And right now, when it's running, we have the X part, but Lexan. We're currently cutting out a piece right now.
This is our programming room. This is where we do all of our software,
It's also nice
mostly.
and cozy in here.
This is also the only room in here that has a heater.
Also a brand new thing of mice for our shop that I brought in.
So we actually recently got a bunch of new computers from MTSI, right? Yeah. That was pretty nice.
And
Pretty small.
this one hasn't been opened yet, but this is one of the controllers that we use to actually use during teleop to drive the robot.
3D printers.
There are 3D printers. These don't work.
They aren't working right now. They used to work really good, and they probably still would work very good, but this one has a wiring issue, and this one we have used it very long time.
This is one of our mentors, Chris.
Yeah.
One of our programming mentors. Okay. You wanna?
Okay, we're pretty much finished with the shop tour, Dave.
Really nice. I'm glad to see you guys making use of that space and learning to use some of the machine tools. I find that interesting, and also find it interesting they're sponsored by Haas. I went to the first maintenance class that Gene Haas put on many years ago. That was part of my career, was with Haas machine tools. So I appreciate that. Thank you, guys. Mark, we appreciate you taking the time and mentoring this group, representing the DMA in the STEM world. So congratulations and thank you.